Why are diagonals important for polygon properties? Imagine trying to understand a complex shape without looking inside it. Diagonals are like secret pathways that reveal what's happening beneath the surface of a polygon. They are line segments that connect to non-adjacent vertices, crossing through the interior of the shape. These lines are more than just connections. They are tools that help us analyze and understand the structure of polygons. The number of diagonals in a polygon depends on how many sides it has. To find out how many diagonals a shape has, you can use a simple formula. Multiply the number of sides by 1 less than the number of sides, then divide by 2. For example, a pentagon has 5 sides, so the calculation would be 5 times 4 divided by 2, which equals 10 diagonals. This formula works because from each vertex, you can draw diagonals to all the other vertices except itself and the 2 next to it. Diagonals are also useful because they break down complex polygons into triangles. Triangles are the simplest shapes with well-known properties. When you draw diagonals inside a polygon, you create a network of triangles. This makes it easier to find the area of the shape by adding up the areas of all those triangles. It also helps in understanding the angles inside the polygon and how they relate to each other. In real-world applications, diagonals are very important for strength and stability. Think about building a house or a bridge. Adding diagonals to rectangular frames turns them into triangles, which are very stable shapes. This is why many structures use diagonal braces to prevent them from wobbling or collapsing. In engineering and construction, these diagonal supports are essential for safety and durability. Different types of polygons have unique diagonal properties. For example, in a square or rectangle, the diagonals are equal in length and cross at right angles, dividing the shape into for equal triangles. In a rhombus, the diagonals are perpendicular but may be different in length, which affects the shape's symmetry and how you calculate its area. Recognizing these differences helps us classify polygons and understand their special features. In advanced fields like computer graphics, diagonals help in rendering complex shapes. When computers need to draw or analyze irregular polygons, they often break them into triangles using diagonals. This makes calculations faster and easier, especially for creating realistic images or models. So, diagonals are important because they show us the inside structure of polygons, help us find areas and angles, improve the strength of structures, and assist in classifying different shapes. They turn complicated shapes into manageable parts, making geometry simpler and more practical to work with.